Okay, ma'am. So good afternoon, all of you, ma'am. This class we are going to discuss about 01 knapsack using branch and bound. Okay. Until now, you may know to solve this 01 knapsack problem using many different way. Maybe like you have learned about greedy method, dynamic programming method. Also, you know how to solve zero knapsack using backtracking. So now we are going to see how to solve this zero knapsack using branch and bound. Let's see an example. Then you will be understanding why it is called as branch and then bound. Okay, let me take an example. So you all already know what is zero one knapsack. So we want to fill the knapsack, and zero one means either you have to take the object completely, or else you should not take it. So that is why we call it as zero one. It is not fractional. And then one more thing is this branch and bound generally used for minimization problem. So whenever we want to get the minimum result, in that cases you will be using branch and bound. But you know, zero on knapsack, what we want is we want the maximum profit, right? That is what the expected result in zero on knapsack. We have to fill the knapsack. At the same time, we also want to gain the maximum profit. So this is zero knapsack is generally a maximization problem, but branch and bound can only help in minimization problem. So what we are going to do is we are going to make it this as a minimization problem, and then we are going to work on it. So for that, instead of a positive value, we are going to consider it as a negative value. So that will help us to work with the branch and bound algorithm. Okay, to make you to understand it little more clear, let us take an example. As usual, we are going to take a profit. So the profits are 10, 10, and we are going to have four objects, 12, 80. And what is the weight of each and every object is? Let us take it as item number 1, 2, 3, and 4. Okay, for each and every one, let's take a weight as 2, 4, 6, and 9. So here we know the n value is 4, the number of items is 4, and the maximum capacity of the knapsack is 50. Okay, this is the capacity, and this is the number of elements or number of items we have to accommodate in the knapsack. So if you want to solve it using branch and bound, here again we are going to use state space tree. You know what is state space tree already. We have used state space tree even in the backtracking also. Then we are going to discuss about the formula which you are going to use on it. So here in the state space tree, for each and every node, we are going to calculate two values. Okay, what are the two values we are going to calculate? Is one is upper bound. Okay, one is we are going to calculate the upper bound. The formula to find the upper bound is minus of the summation of the object and into xi. I'll tell you what it is when I equal to 1 to n. So for all the four items, we are going to sum up all the profits. Okay, what is pi is the profit we know. Xi mentions whether we are going to consider that object or we are not going to consider the object, which means xi can be either 0 or 1. So pi is the profit into the xi value, which means are you going to take the object or not going to take the object. For example, if I say when I take x1, then xi will be 1. And if I take a not to consider the first item x1, then I'll say it is 0. So this is that 0 or 1, and this specifies, pi specifies the profit. Okay, this formula helps us to find the upper bound. And one more thing here you have to remember is here we are going to find the sum of all profit, sum of the profit, as well as when you calculate this upper bound, we are going to take it without fraction. Okay, without fraction, that is also you have to keep in mind. Without fraction means we already know whenever we take an element, either you have to take it completely or you have to we should not take it. So Without fraction, only we will be calculating the upper bound. And the next thing we have to calculate is the cost. So this we have to do for each and every node, okay? So how to calculate the cost is, it is again same thing. Cost we will be calculating minus of. As I said, since we are going to work with a minus, which means minimization problem, we are going to convert the positive numbers into negative numbers and we are going to do it. And finally, we'll convert back to positive, okay? Since zero knapsack is a maximization problem, but still branch and bound will work for the minimization problem. So that is why we are going to convert each and every value to a negative value. So here again we are going to find the summation of the product of the profit into xi. Again pi means profit, xi means are you going to consider the item or not going to consider the item. But what is the difference between these two is, when you calculate the cost, you have to calculate with fraction. Even though we know 0 1 knapsack means we won't take any item as a fractional one, but still, when you calculate the cost, you have to take it the fraction part also. So if you know these two things, you can able to do this problem. So remember about the upper bound, and so in that we are going to sum up all the profit, and in the without fraction, and in the cost again we are going to sum up all the profit but with fraction. So each and every object you have to calculate this. Let's start working on it. Okay, so to remember, to know out the profit and the weight, let me write it once again: 10, 10, 12, and 18. And then the weight is 2, 4, 6, and 9. Okay. So we are going to draw a state space tree. So we have a node. So initially, before we start working on it, what we have to do is we have to initialize an upper bound, a common upper bound. Okay, so let us say we are going to initialize initially a common upper bound. So initially we don't know what is our upper bound. So let us make it as infinity. Since we don't know what is the upper bound in the initial state, so we make it the upper bound as infinity. Then let us start working on it. So first we are going to make the root node of the state space tree. For this root node, we have to find what is the upper bound. Okay, what is the upper value, upper bound value, and also we have to calculate the cost. So we already know how to calculate the upper bound, the total of all. Okay, so how to calculate the upper bound? So the formula we already know to calculate the upper bound is sum of all profit. So what we are going to do? We are going to sum up all the 4 items are there. So 10 and its profit, 10, its profit is 4, and then 12, its profit, 18, its profit. So we want to find the sum of all. And if you find the sum of all of this, what will be the answer you will be getting is so 10, 20, 30, 40, 42, right? One second. Okay. So we want to calculate the upper bound, and also we want to calculate the cost. So here let us consider the first item. Let me consider the second item. And when we consider the third item, what will be the weight? 2 plus 4 is 6. 6 plus 6 is 12. So now we got I 12. But when I add this 9 along with this, actually the maximum capacity we know the M value is 15. So when I take consider this 3 item itself, it become 12. So I cannot add this 9 with this 12, right? Because our maximum size of our knapsack is 15 only. So I can take 2 plus 4 plus 6, that is 12. So I cannot consider this 9. So if I want to, when I calculate the upper bound, we said that when you calculate the upper bound, we have to sum all the profit without the fraction. So in that case, without the fraction, if you calculate the profit, you will be summing up all this. So 10 plus 10 plus 12 is 32. So the upper bound is 32, but we know we have to add a minus to it. So it is minus 32. But also we discussed whenever we calculate the cost, we have to take the fraction of it. So we know that we by considering these three items, we got the weight is 12. So what is the remaining weight? 3, right? Because total size of the knapsack is 15. So 15 minus 12, we will be getting 3. So because 3 more spaces there. So how will we take? We are going to take the fraction of this fourth item. So how will we take? We will be taking 18 divided by 9 into 3. Because 3 is the 3 more spaces available. So when we do solve it, it will go for 2, so 2 threes are 6. So now we are going to take the fraction part of this when you calculate the cost. So now we have to add all this profit. So it is 10 plus 10 plus 12 plus 6, right? So it become 30, 38. So it will be minus 38. So always keep in mind whenever you calculate the upper bound, but you should keep this in your mind. The size of the knapsack should not exceed 15. That is always same condition. But when you do for the upper bound, so without fraction, we will be adding this 3 profits. Because when I take the fourth item, it exceeds the size. But when you go for the cost, you can take the fraction part also. So the remaining space in the knapsack is 3 as we got from here. So we have to find the fraction of it. So it is 18 divided by 9, right? So for one item we are getting, and into what is the remaining space, we have 3. So into 3, so that we will be getting 6. So when we get the sum of all this together, we will be getting minus 38. Okay, so this is how we will be calculating the upper bound and the cost for the first note. And after we find it, every time you have to check whether we want to update the upper bound or not. Whenever we get an upper bound which is less than the initial one, then what you have to do means you have to update commit. You can update the upper bound. So initially it is infinity. Now when you update it, you can update it by minus 32, because whenever we get less upper bound, you can change it. Okay, so minus 32. So minimum value, always you can update the upper bound with the minimum value, that is minus 32. Okay, so every time you have to check that as well. So the next thing is we are going to consider proceed with this. Now as we do, every time we are going to take one item and we are going to check whether can I add this item or not, like that. So when I consider the first item x1 equal to 1, which means what, when I consider the first item, which means we are going to, first item also is included in the total. So when I even consider the items, I'll be getting the same answer, because in the calculation we are going to consider the first item also. That is the meaning. So there will not be any change in the upper bound and the cost. Same thing you will be getting. So here again, your upper bound is minus 32 and your cost is minus 38. And this is the second node. And let us go for the third node. So then you have to find the third node. Here again you have to find the upper bound as well as the cost. In this case you have to say, when I don't consider the first item, what will be the upper bound and what will be the cost. That is what we want to find. So here we are considering the first item also in the total. So altogether we'll be getting the same result. Here we are going to say, when I don't include the first item, how does our problem will be. So we are going to solve for it. So usually we know our items are 10 and its profit is 2. Profit is 10 and the weight is 4. Profit is 12 and the weight is 6. Profit is 18 and the weight is 9. Now we said don't consider the first item. When we don't consider the first item, we are going to check the upper bound and the cost. In that case, so we are calculating this too. So when I take the first item, it is 4. Second item, third item is 6. So 4 plus 6 is 10. But when I add the 9 also with it, it becomes 19. So it exceeds the maximum size. So we cannot consider this fourth item into it. So for the upper bound, we have to add this 2 alone because we don't consider the fraction of it, right? So the upper bound become minus 22. Hope you got why we added minus. It's a minimization problem. Based on the formula, I have to add the minus. So, but when you calculate the cost, we know as usual, we have to take the fraction part of it. So, how will you take the fraction part of it here? So, the total size of our knapsack is 15. 15 minus 10, because already we are taking this 2. So, 15 minus 10, we'll be getting the answer is 5. So, how does it will be working? So, how it will be doing is, so it will be coming like here we have to take 18 divided by 9 into 5. So that is the fraction part of it. So when we do calculation, 5 2s are 10. So we'll get the answer as 10. So now when you calculate the cost, we have to sum all this. 10 plus 12 plus 10. So you will be getting 32. So we know that we have to make it as minus 32. So this is the cost. Okay, so without considering the first item, this is our first item. Without considering the first item, we calculated the upper bound. When we calculate the upper bound, don't consider the fraction, but when we calculate the cost, consider the fraction. That is the only thing you have to remember. Okay, after you finish every level, one more thing you have to check is you have to check whether we got any upper bound less than this minus 32. So here you can see the upper bound here is minus 32 and here the upper bound is minus 22. So we didn't get any value less than minus 32. So if you see this upper bound, it is minus 22. It is greater than minus 32, right? And if you see the upper bound of this node, it is equal to the upper bound. So we don't want to do any updation in it. Okay, and the next thing is, next you have to think, now in this time we have two nodes. Out of these two nodes, by which node we have to proceed. So that is we want to know. In branch and bound problem, we have many different method. One is FIFO branch and bound is there. LIFO branch and bound is there, and also LC branch and bound is also there. There are different methods available. In all these three methods, FIFO means first in, first out. LIFO means last in, first out. And LC means least cost branch and bound. So in our problem, least cost branch and bound is the fastest one. If you can also do with first come, first out. Who came first, we can solve that first. That involves some more steps than the least cost. So the least cost is the faster one. So out of all this branch and bound, we are going to proceed with this least cost method. So if you consider this two, who have the least cost, here the cost of the second node is minus 38 and the cost of the third node is minus 32. So who got the less cost? In this case, the less cost is this one. So now we are going to proceed with the second node. So let us consider the second node. So again, how will I proceed here is, I'll be telling when I include the second object. So when I include the second element or second object, how it will be coming? So when I'm saying that I'm going to include the second item also, which means all the items are there. So there will not be any change in the upper bound and the cost. So I'll be getting the same thing as upper bound is also minus 32, cost is also minus 38. The same value of this because there is no change. Second item is also included. Okay. So now the next thing is you have to calculate this as well. The fourth node. Here I have to say when I don't consider the second item. That also we have to calculate. So let us calculate it. So here, what are the elements and the profit? First item profit is 10 and the weight is 2. Next item is 10, 4, 12 and 6, 18 and 90. This is what the question. Now we said we are not going to consider the second item. So already we said consider the first item but don't consider the second item. So if I don't consider the second item, we are not going to include this. Okay. Other than that, we are going to calculate it. When you calculate it, we'll say 2 plus 6 is 7, 8, right? And 8 plus 9, it crossed the maximum size 15. So 2 plus 6 is 8. So the maximum size is 15. So 15 minus 8, what is the answer you will be getting? 7, right? Why? Because we are not including this 9. When I include this 9 also, 9 plus 8, you will be getting 17. But you know the maximum size of us is 15 itself. So we cannot cross it. So we are not going to include this item into it. So we are taking only this 2 for calculating the upper bound. So when I take upper bound calculation, I'll be calculating without fraction. So 10 plus 12 is 22. So here the upper bound is minus 22. Okay, then we have to calculate the cost. But we know that when we calculate the cost, we have to consider the fractional part also. So how will we calculate the fraction part? So here we will be doing 18 divided by 9. And then what is the remaining place there in the knapsack? We got it 7. So into 7. So 9, it will go for 2. So 2 sevens are 14. So now we have to add 10 plus 12 plus this 14. We are going to take the fraction part of this. So that is 14. So you will get 36. So the cost is minus 36. Okay, so in the upper bound, we won't take this fractional part. The rest alone we'll be taking. So here in this case, we'll take this item and this item. Because if you take this item, it crosses the maximum size. So that is 10 plus 12. But when we calculate the cost, what is the remaining space in the knapsack after taking 8? 7. So accordingly, we are going to find the remaining place. So 18 divided by 9 into 7 is 14, and we then add all this thing together, we'll get minus 36. Okay, now we got all these things. Okay, every time I said after you calculate all the nodes, upper bound and the cost, first you have to check whether we want to update this upper bound or not. Do we want to update this upper bound? So when will we update this upper bound? Whenever we get a upper bound value which is less than this value, then we have to update it. If you see here, the upper bound is minus 32, it is equal. Here it is upper bound is minus 22. So it is greater than this, so we cannot update it. Here also it is minus 22, we cannot update this. So always the upper bound should be a lesser value. So we don't want to update the upper bound here. Okay. The next thing we have to calculate here is, one more thing you have to remember here is the cost, no? The cost should not be greater than the upper bound. Whenever the cost is greater than the upper bound, then we have to kill that one, which means what we are going to say is we are going to stop proceeding in that. Okay, that is, we are going to bound it. We are going to stop calculating there. What we are going to see is, if you see here, in this case, if you see, we want to check whether through which way we are going to proceed, that we have to understand first. And if you see here first, before we proceed, we have to check this. As I told here also, who have the lesser cost, and that cost only we have to proceed. And if you see the cost also, this cost is also equal to this, no problem. This cost is also lesser than this, so no problem. And this cost is also lesser than this, so no problem. We don't want to kill any of this node. I hope you got it. Every time before you proceed, you have to do two steps. One is we have to check whether we want to update this upper bound or not. So how will we, when you update the upper bound, whenever the upper bound value is lesser than this, then we have to update this value. But no upper bound value is lesser than minus 32. It is only equal here. So we don't want the upper bound. That is the first thing you have to check. What is the second thing you have to check is, if any one of the costs, first we checked with upper bound. If any one of the cost is greater than this upper bound, then we have to kill it. But in this case, this cost is equal to it, no problem. This cost is also lesser than this, no problem. This cost is also lesser than minus 32. So no problem, we can proceed. Next question is, by which node we want to proceed. So as I told you, which one have the lesser cost, through which that way only you have to proceed. So when you see in all these three nodes, this third node, fourth node, and um, this is fourth node, right? 4 and this is 5. So out of this 4, 5 and third node, this one, the fourth node cost is minus 38, which is the lesser value. So we are going to proceed with that. Okay. When I proceed with that, what will we say? When we consider the third item, what will be our upper bound and lower cost? So same value only we will be getting because we are including that as well. So the cost is also minus 38. So this is node number 6. Then next is in the node number 7, which means we say when we don't include the third item, what will be the upper bound and the cost that we have to calculate now. So how will we calculate? Again, I'm going to write again the profit and the weight of each and every item. So now what we are going to say, when I don't include the third item, which means what? I am not going to include this third item. So I'm going to delete this. So third item is not included. That is what we said here. So now we want to see who all we are going to include. So if we say 2 plus 4 is 6, 6 plus this 9, what is that? 15. So we correctly got it. So there is no need of calculating any fraction in it. So directly we can take the upper bound also. What is the upper bound? 10, this one. 10 plus 10 plus 18. So we will be getting minus 38. And how to calculate the cost? Again the same thing, 10 plus 10 plus 18. So I'll be getting minus 38. Okay. So here I hope you got it. We are in this case we are not going to consider the third item. When I don't consider third item, we have to check whether the maximum size is within the knapsack size. So when I consider all these three, 1, 2 and the fourth one, it is within the range only 15. So we don't want to consider any fraction, just include all the profit. 10 plus 10 plus 18, the profits. Okay, we are calculating the profit. Okay, we done with that. So as I said, after we finish every node branching, then we have to see whether we can bound anywhere. Bound means we are going to stop proceeding from that particular node. That is when we say as bound. And then we branch in on the minimum cost node, that is branch. So now we have to see whether, what is the first thing I said already? Every time after you branch, you have to check whether any of the cost is or any of the upper bound which we have is lesser than this. So if you see this is not lesser, this is not lesser. Now you can see this minus 38 is lesser than minus 32. So now what we can do? We can update it. How will I update it? Instead of minus 32, I'm going to update it as minus 38 because minus 38, that is the upper bound of this node, which is lesser than minus 32. I'm going to update it with minus 38. Now our upper bound is minus 38. That is the first step, right? After that, what I said, second step, what you have to do is now we have to check with the cost. Whichever node the cost is greater than minus 38, we have to kill it. We have to kill those nodes. So that is what bounding, we are stopping it. So instead of simply branching through this ways and wasting the time and the cost, we are going to just bound it. So first let us check with this. So what is the cost here? Minus 32. So minus 32 is greater than minus 38, right? So the cost should not be greater than the upper bound. So here it is greater. So what you have to do, you have to kill this node. You kill it. And here you see, in this node, node number 5, what is the cost? Minus 36. Minus 36 is greater than minus 38. So kill it. Okay. And then, if you see here, the cost is minus 38. And here also it is minus 30 is equal, no problem. And here also, if you see, here also for the sixth node also, the cost is minus 38. It is equal to the upper bound, so no problem. So now we have bounded two things, which means we have stopped two nodes so that it will not proceed. Okay. Now you can see now we have two nodes 6 and 7, both are having the same cost, so we can choose any one. So now I am going to proceed with the sixth node. So when I proceed with the sixth node, what will I say? When I consider x4 equal to 1, which means I am going to include all the four nodes. But you know that what are the four nodes? 10, 10, 12, 8, and its weight is 2, 4, 6, and 9. So if you see, if I add all the four items into the knapsack, we know that it will exceed the maximum size of the knapsack, which is 50, because 2 plus 4 plus 6 is 12, 12 plus 9, it is like 21. So it is exceeds the size of the knapsack. So this way I cannot proceed because it is exceeding the maximum size. So we know that we cannot proceed in this, right? So then what again I can do here is, you can also check, like, when I don't include this fourth item. Okay, when I don't include the fourth item, I will getting the same thing only. Because if you don't include the fourth item, this is until this, right? When I include the first three item, that is the meaning. So the seventh node, upper bound is also minus 32, cost is also minus 38. Because you know this, this is 18, right? When I don't include the fourth item, 10 plus 10 plus 12 is 32, and cost is also 32, right? Oh, no, no, no. How will you calculate the cost? We have to include the fraction also. So here, 12. So already we have calculated. 12, the remaining is 15 minus 12 is we will be getting 3. So we have to find the fraction of it. So when you calculate the fraction, we have already calculated is here. 18 divided by 9 into 3. So you will be getting 6. So 10 plus 10 plus 12 plus 6 is minus 38. So this is what the value will be getting when I don't consider fourth item. Okay. So now if you now we have at present we have two nodes in our hand. This is node number 8. So at present we have two nodes here. And again we have to check whether any of the cost is lesser than the upper bound cost. No, nothing is lesser than it. And then we have to check the cost. The cost is also not greater than it, right? Uh, okay. So we can okay. So now we will be proceeding with this, any one of it. So here, if I go it, we don't have any more node here, right? Because we cannot proceed here. So we can stop it here itself. Okay, we cannot proceed further here because we don't have any more item because totally four items only there. So we will be proceeding here, okay, with this seventh node. When we proceed here, what are the nodes I'll be getting? Node number 9. So in this, what are the things you will be getting? I'll be erasing all this unnecessary things. Okay, so in this case, so we cannot proceed. So I'll be deleting this as well because we don't have any other item to proceed there. So now let us write this. So I'm going to include the eighth item here. And in this case, what will I put when I include the fourth item as 1? Because here we have stopped with x3 as no. Now we are going to say when fourth item is included. So what is the case? 10, 10, 12 and 18. Its weight is 2, 4, 6 and 9. And we are going to say when we include the fourth item. But in the previous step we have said third item is not included. So when the third item is not included, you will be getting the same result only, right? So here again you will get the upper bound is minus 38 and the cost is minus 38. Okay, and then we have to say when I don't include the fourth item, what will happen here? That is what we are going to see. So third item is also not included. Fourth item is also not included. So that is what coming here. And in this case, so if you can see, third item is also not included, fourth item is also not included. Okay, so what will be the upper bound and the cost? Upper bound is this when you add this 2, you will get 6 only. Okay, So we can include this too. So we'll be getting minus 20. And the cost also, we are not going to include this too. So there is nothing to take the fraction also. So here again, you will get the cost as minus 20. Right now, I said now we finish this branching of this node. When we finishing the branching of this node, you know that first thing you have to check it, we'll be checking whether the upper bound is updated or not. So here you can see what is the upper bound minus 38. Do we get any upper bound which is less than this minus 38? No. So you can see as of now the upper bound here is minus 38. Now, if you see this upper bound, it is equal. This upper bound is not lesser than minus 38. So, we cannot do anything, any updation in the upper bound. And what about the cost? We said that whenever the cost is greater than this upper bound, we have to kill the node. That is the second condition we learned. So, first condition, we have to check whether do we want to update this upper bound. Now, whenever the upper bound is lesser than this minus 38, so if we don't have any node which is lesser than this, so that we are not doing anything. Next, second thing you have to check is you have to check whether any of the cost is greater than this upper bound. So here you can see this cost minus 20, which is greater than minus 38. So you have to kill this now, right? So now that's it. We finished it. Now we can see only one node is left over. So this is our solution, right? So all the other nodes are killed and there is no other way to proceed because we have included all, we have checked for all the 4 items and the item who is left at the last will be the solution. So when you see the solution, you have to answer the solution in this manner as you can see whether the first item is included here, yes. So the item x1 is present. X2 is also present. X2 is also present. You can say X2. And when you come here, X3, X3 is not present. X3 is not present. And when you see X4, X4 is present. You can see it is 1. 1 means it is present. Now, when you calculate the profit of it, so first item profit is 10, second item profit is 10, third item we are not going to include, fourth item profit is 18. And what is the total? It is 38. So we got the cost, right? Correctly. And then what is the weight? Have we calculated the weight properly? So what are the weight we have? The weight are 2, 4, right? 2, 4, 6 and 9. So here it is 2, 4, 9. So this is not included, right? So what is the answer? 2 plus 4 is 6, 6 plus 9 is 50. So this is the weight, we correctly classified the weight, and this is the profit we got. So we got here the profit also, the cost is 38. So when we get the answer, we have to maximize, convert into maximization. So we have to ignore this negative sign. So we have to take it as positive. So we got 38 as our answer and the weight of the knapsack is 15 and we also correctly fitted the value also. So we are going to consider the result. If you see, the final result is this. So we are going to include the item number 1, 2 and 4 in our knapsack with a profit of 38. So this is what branch and bound problem is. What is branch? We are going to see where we want to branch and whenever we can stop some node not to proceed, we are stopping it, that we count as bound. So that unnecessarily we don't want to go there and calculate it. We know generally if you calculate all, the cost will be in exponential. If you go through all, if you expand all the nodes and if you find who is the best solution, if you expand all it, it will be in the exponential order, the time complexity. But when you do it with branch and bound, again an optimization problem. So to solve optimization problem, this branch and bound will also reduce the time complexity. Okay, so I hope you got it. If you have any doubt, you can go through it once again so that you will understand it clearly. Okay, ma?